We're going to do a quick lesson on graphing quadrilaterals and then using the graph, using the information on the graph to determine whether or not the quadrilateral is a parallelogram. Okay, so here's what we have. We have an instance of a quadrilateral graphed in the xy coordinates, an xy plane, and we're given this information. We have each of the x and y points for each of these points A, B, C, D, and we're given the instructions show that A, B, C, D is a parallelogram by using the definition of a parallelogram. Well, if you remember, the definition of a parallelogram is that it's a quadrilateral that has two pairs of opposite sides being congruent. And actually, I'm just going to type that out. Parallelogram is a quadrilateral that whose opposite sides are parallel. Okay, so in order for us to prove that, misspelled parallel, in order for us to prove that this quadrilateral that is in this xy plane is actually a parallelogram, we have to somehow prove that this side is in fact parallel to this side and that this side is parallel to this side. Okay, so to fulfill what this question is asking us, we need to somehow use these points to prove that the opposite sides are parallel. So if you remember, we talked about this already this year, maybe you remember this from algebra, but if two lines are parallel, then they will have the same slope. Okay, so parallel lines have the same slope. So what we need to do is we need to find the slope of this line and see if they're the same. So let's do that. Remember, slope, the symbol for slope is m, and the slope formula is y2 minus y1 over x2 minus x1. Okay, so I'm going to do that first with B and C. So here's B and C. I need to do the slope formula with B and C to see what the slope is. So I'm going to do that. So here's B, here's C. Y2 is 5. Y1 is 3. So I need to do Y2 minus Y1 is 5 minus 3. X2 is 6. X1 is 1. So X2 minus X1 is going to be 6 minus 1. So what we have here is 5 minus 3, which is 2, over 6 minus 1, which is 5. So the slope of this line BC is 2 over 5. Okay, so I'm going to come over here, and now I'm going to do the slope of this line to see if it is parallel to that line. Okay, so now I'm finding the slope between points A and D. Okay, so we have y2 minus y1, which is 1 minus negative 1, 1 minus negative 1, over x2 minus x1, which is 7 minus 2. Okay. 1 minus negative 1 is the same as saying 1 plus 1, so that's 2. 7 minus 2 is 5. So in fact, these two lines are parallel. Why? How do we know they're parallel? Because they have the same slope. Now I need to go back, and I also need to do that with this line and this line. So I'll start with this line first. That's A and B. Okay, so now I'm going right here. Y2 is 3. Y1 is negative 1, so I'm doing 3 minus negative 1 over x1. X2 is 1. X1 is 2, so 1 minus 2. That equals 3 plus 1 is 4. 1 minus 2 is negative 1. 4 over negative 1 is negative 4. So that line has a slope of negative 4. So if this is a parallelogram, then this line will have the same slope. Its slope should be negative 4. So y2, 1 minus y1, which is 5, x2, which is 7 over x1, or minus x1, which is 6, is 7 minus 6, and that gives us 1 minus 5 is negative 4. 7 minus 6 is clearly 1, so it has a slope of negative 4. So in a xy plane, if we want to prove that a quadrilateral is a parallelogram, we need to see if the opposite sides are parallel, and thus we need to figure out if they have the same slope. Okay? So here is an example problem, and I'm actually not going to give you the notes for this. So I want you to draw this in your notes, and I want you to do the same thing that we just did. So different problem, and I want you to go through, and I want you to show that ABCD is a parallelogram by using theorem 6.6. Okay, so that's a hint. That is a hint. Go find theorem 6.6, see what that says, and figure out how to use that to show that this is a parallelogram.